In this video, we'll look at the gear assignment. Here's the finished product where you're asked to make a 46 tooth gear here. So let me refer back to, oops, that's the wrong one. There it is. So the table of information you have here is that we're building a 46 tooth gear. Diametral pitch is 6 teeth per inch, so we can figure out what the pitch diameter is by dividing 46 by 6. We have a standard pressure angle, a standard addendum and dedendum, and then a request for a fillet at both the root and the tip of each tooth with 3/8 inch width material and a 3/8 inch hole diameter. So the goal is to get to this part, but there is a fair amount of work to get this far. And interestingly, probably the hardest part is to get this very first sketch put together. So let's come into here. One of the things, so the steps of making this sketch is to set up your 4 circles. And in this particular case, my circles are not in the normal order. So usually we have the dedendum, the base, the pitch, and the addendum circles. In this case, the dedendum is actually a larger diameter than my base circle. So that's just the nature of this particular gear diameter dimensions. So I put in my 4 circles, and then I put in the points for my gear tooth. And recall that a gear tooth, the ones that we are designing for this assignment, is an involute profile. That involute profile starts at the base circle, and it's as though you are unraveling a string and keeping it taut and following where the end of the string goes as it unspools. So that's the nature of this. I actually have, can you see I have far too many points, but that doesn't affect my model. And it does mean that if I was to modify this model for different information, I still have some extra points out here that I might use. So not a problem that my tooth profile goes well off into the into nothingness. My gear tooth stops at the addendum circle. So let me just show you in a brand new part what this process looks like. So I'm going to put a sketch on the front plane, and I'm going to put in 1, 2, 3, 4 circles. 2 of those circles are construction circles because they are not actually circles I can see on the physical part. The pitch circle is the where the gear tooth thickness is equal to the gap thickness, right? So it's kind of a theoretical, can't see it sort of circle on this gear. And then the base circle is where the involute curve starts from. Again, can't really see it. So those are my 4 circles. And then I'm going to grab the point tool, come out here, and I can go ahead and start on the, I'm actually just going to start over here. And then I'm going to make a linear pattern, and we'll do this again very similarly with the wing. So I'm just going to make a series of points. I'm also going to count. I think I made 13, 10, 11, 12. So we'll go ahead and do 12 at the moment. So I'll turn off my point tool. So the next thing I want to do is I want to fully define the sketch. I insert, or I go to Tools here. Tools, Dimensions, Fully Defined Sketch. All entities in Sketch, hit that check mark, and now my sketch is a bit of a mess, but it's fully defined. Now if I, on the visibility toolbar up here, turn on dimension names, now I can see that they each have a name. So if I click on the arrow here, and I gotta be careful not to get the dimension. Here we go. On the left, so this is going to the dedendum. So I'm going to call that the dedendum. And here, this is the base. And this is the pitch. Okay, so you see what I'm doing? Now the next thing I need to do is I need to name all these dimensions. This is x1. Oops. and this is Y1. Now it doesn't actually matter that x1, x2, etc. are sequential, but it does matter that x1 and y1 both go to this point, x2 and y2 both go to this point, etc. So my goal here is to get a fully named dimensioning sequence where my last dimension is x13, y13, or however many points I have, and all of my circles are also named. So this outside one is 8, 10, 10. Okay, so once you've finished naming all your dimensions, we're going to insert table, design table. And defaults are perfect, checkmark puts it in. And now it's going to ask, what do you want to include in your design table? And we're going to choose everything. Now yours should be properly named, right? X1 through X13, Y1 through Y13. Put that in, and there's our design table. And it's basically an Excel window that opens up in SolidWorks. So I'm going to go ahead and close out of this and show you that at this point now, all of those dimensions turn magenta. Indicates it's covered by that design table. So I'm going to exit out of my incomplete sketch and go back into my complete sketch, and we'll finish that design table together. Okay, so I can open my, so what I recommend that you do at this point is close out your design table and then right click on it. You find it on the configuration manager, right click, edit in new window. Excel is much easier to use in Excel rather than in SolidWorks. Let me get this into our video window here. Let me show you how I set mine up. So number of teeth, diametral pitch. My pitch diameter is n divided by p. So you can type equations into Excel and you can reference the other cells. My theta I turned into radians. So it's 20 degrees, and in pi radians there's 180 degrees, right? Half a circle is 180 degrees. It's also pi radians. Excel doesn't do trigonometry with degrees, so it's easier to work with radians. My addendum is 1 over the diametral pitch. My dedendum is 1.25 over the diametral pitch. We usually want our dedendum bigger than our addendum. This gives us clearance. So now I'm going to start assigning these based on my relevant information right here. So that's my pitch diameter. My base diameter is the pitch diameter times the cosine of the pressure angle. My dedendum, I subtract twice. This is my dedendum diameter. I subtract twice the dedendum. Addendum diameter, I add twice the addendum. I also have my x values, and that comes from the involute down here. So I'm going to use the base circle radius, and then I'm going to use the equation of the involute curve. Cos theta equals theta sine theta for x, sine theta minus theta cos theta for y. I was tracking my points here. This is just my number. Okay, so the last thing to do would be to select all my cells here, and I type equals transpose, and I go and I find the column, and I hit Control Shift Enter, and that transposes and it links them. So if I was to change anything here, it updates there. So you can do a copy paste with transpose. Maybe you're savvy enough in Excel to know that, but it doesn't link them. This process links my row here to my column there. Do the same for your Y and you're done. And when you close out of this window, it should update all those points. And so what you would have is, let me see, if I take that out, let's take out my mirror as well. So you would have these points, and you would probably notice at that point that your base circle and your dedendum are in the wrong order. So now we're going to make that spline and mirror it. The mirror line, this construction line goes from the center of the gear to where the spline intersects the pitch circle, and this just goes out to the pitch circle, and the angle between them is the number of degrees in a circle divided by the number of teeth. This is really half, right? So I'll divide by 2. And then I actually need equal number of teeth and spaces, so I'll divide by 2 again. SolidWorks is great at pretty basic math. Didn't do so good there. Hold on. So we'll do 360 divided by 46 divided by 4. Oh, there we go. Back to the right number. And then I can mirror my spline across. So pretty soon here, this is going to get to be a very large video. So I'm going to pause after I show you this next step, and then I'll show you some more of the details in a second video. So the first thing I do is extrude the dedendum circle. The second thing I do is extrude a single tooth. The third thing I do was the fillets, and you could probably do this in one step. And then finally, a circular pattern that puts in 46 of them and my central hole. So that'll wrap up this video. I'll get you some more details in a second follow-up video.